Okay, it's 3 minutes after the scheduled time, so let's start. Hello, everyone. My name is Marcin Wielgus, and I am very happy to welcome you on the introduction to autoscaling. I'm not sure about you, but I love late November. Everything is starting to slow down, and people begin to switch their focus from job-related topics to something a little bit more pleasant, like best recipes for Thanksgiving dinner, choosing Christmas present for their loved ones, planning New Year's party, hunting for the best Black Friday, Cyber Monday deals, or simply thinking how to use the remaining of their paid time off. And the last thing you would like to get during Thanksgiving, Christmas, Black Friday, or vacation, or actually at any time, is an alert that your cluster has problems. So you prepare. You add logging, monitoring, alerting. You check whether your applications are well configured. You do load tests and analyze traffic, first to validate the apps themselves, but also to answer questions like, how many pods should I have in my deployment? How big the pods should be? How much resources do I need in my cluster? And these are not easy questions. Of course, lots of measurements, tests, checks, and validations can be performed. However, most of technical people don't have strong clairvoyant skills. And life will always find a way to surprise you. Proper pod count for today, maybe too little for tomorrow when the traffic increases. An absent-minded developer may forget to mention that they increased the cache in the application 10 times just to be on the safe side on Black Friday, and now the app is starting to throwing out of memory exception. Someone may start another workload in the cluster, depleting its capacity. And you will be called to fix it. According to Murphy's laws, more likely at the worst possible time. And obviously, you don't want to be woken up in the middle of the night or interrupted during vacation. You would like to have an automation, a robot who would observe your cluster and add or remove computational capacity when needed to keep your workloads healthy and, at the same time, to keep your monthly bills low. Luckily for you, we have a couple of such robots in Kubernetes, and now I'm going to describe them to you. The first robot is called Horizontal Pot Autoscaler. Horizontal Pot Autoscaler is based on metrics that express the load that the application gets. It can be either CPU usage or something a little bit more custom, like the number of queries per second, or some other gauge-like value provided by the user. HPA takes the value of the metrics, compares it with the user-defined target, and, depending on this comparison, adds or removes replicas, hoping to move the metrics toward the desired value. Let's take a look on how does it work in practice. But before that, let me clarify something. While talking about HPA, I will use a word utilization. I understand it as a ratio between the current load, expressed by some metrics, and the maximum amount of load that the application can handle. For example, if a pod requested 1 CPU and is using only 0.5, then the CPU utilization is 50%. If a pod can handle, let's say, 1,000 QPSs, but is processing only 200 at this given moment, then the utilization is obviously 20%. Okay, now the mentioned example. On this example, we have 4 pods that are burning hot. They are reporting very high utilization. Their load is above the target. They use almost all of their capacity. Should the traffic increase, there might not be enough computing power to handle it. If we add another pod, then the same traffic will be spread across 5 pods. Then the average per pod load will obviously decrease, leaving more space for the spikes and coming closer to the desired target. If the situation is slightly different and for each of the pods the load is below the target, then it might be actually beneficial to delete one of the pods. Then the traffic on the remaining pods will increase, the pods will be better utilized, and you will have more free resources in your cluster. And this is what Horizontal Pod Autoscaler does. It adds and deletes pod replicas when needed. When to use Horizontal Pod Autoscaler? Horizontal Pot Autoscaler works the best with stateless serving workloads that can spin up new replicas reasonably fast. You can also use Horizontal Pot Autoscaler with other workloads, like something related to queue-based processing and so on. How to enable it? Horizontal Pot Autoscaler is a part of core Kubernetes APIs. HPA is controlled by an HPA object. You created this object either manually with providing YAML definition or by kube-autoscale command. CPU utilization autoscaling is available out of the box. Custom metrics require a little bit more work. Please check the documentation for details. While setting up HPA, it is crucial to set the target value, or more generally, target utilization right. 1 minus utilization is your spike capacity and the driver for scale-ups. Too small buffer may prevent scale-ups and may overload your application. Too big, obviously, causes a waste. The value of the target utilization should allow you to run with the increased traffic, but with the old number of replicas for, let's say, 2-3 minutes, and still have a bit of buffer. So if you expect that within any 2 minutes your traffic may rise by, let's say, 50%, then you should set target utilization to less than 65%. If it can double, to less than 50%, and so on. What are the other best practices for Horizontal Pot Autoscaler? Applications under HPA should correctly handle SIG terms. This means that after receiving this signal, the application should not stop immediately, but finish all of the requests that are in flight and still listen for incoming connection that may arrive after the pod termination begins. Why? It takes a while to update all kube proxies and all load balancers, sometimes even 1 minute. If your application dies before all kube proxies and the load balancers are updated, I mean, your replica dies before all kube proxies and load balancers are updated, some requests may end up in the void, causing errors on the client side. Also, new replicas should not receive requests before they are ready for that. To ensure that, please set up readiness proof and liveness proof, by the way. It's a good practice even without Horizontal Pot Autoscaler, but is particularly important when your pods are constantly starting and stopping. Also, please keep your metrics server healthy. It's the source of CPU utilization metrics, and without it, HPA on CPU will not work. Last but not least, please enable Cluster Autoscaler. While adding new replicas, you may end up without any free capacity in the cluster, and you will need something to fix it up for you. I will talk about Cluster Autoscaler in a moment. What types of savings you can expect from using Horizontal Pot Autoscaler? Simplifying a bit, pods under HPL will request 1 divided by the utilization target more resources that is absolutely needed to handle traffic. So if you set your target utilization to 65%, your pods will be over-provisioned by 50%. Without HPA, you will always use the same maximum amount of resources, most likely over-provisioned way more than 50%. The second robot from our happy autoscaling family is Vertical Pot Autoscaler. Vertical Pot Autoscaler monitors the real CPU and memory usage, as well as out-of-memory events, to estimate what should be the pod size in terms of requested CPU and memory. Pod request is used by the scheduler to decide where to put the pod. Only machine that has enough free resources can host the pod. Pod request also defines how much resources will be guaranteed to the application. If it's too small, then the application may be throttled down or throw some out-of-memory exceptions. If it's too big, then resources are obviously wasted. So it's important to set pod request right. So what a VPA does? Let's take a look at an example. Here we have a pod that uses 95% of the requested capacity for a significant period of time. It is definitely not a healthy situation. And in this case, Vertical Pot Autoscaler will recommend increasing the pod size so that the same load consumed consumes only, let's say, 75% of the capacity, not 95. In the similar fashion, if the load on the pod is low for an extended period of time, VPA will recommend to decrease pod size to free some space and allow better utilization of your machines. Vertical Pot Autoscaler can work in 3 modes. In first, it only provides recommendations but doesn't change anything. The user is responsible for setting this pod request manually. In the second, it only sets pod requests on new pods. It doesn't change the existing pods, even if they have suboptimal requests. And in the last mode, Auto, VPA kills existing pods and recreate them with updated requests if they have these suboptimal requests present. You can use VPA for both stateless and stateful workloads, especially if they cannot be handled by HPA. Obviously, VPA is particularly useful when you have no idea how to set pod request right. And auto mode is very handy when your application can be restarted and you gain enough confidence with VPA recommendations when running it in recommendations-only mode. Vertical Pot Autoscaler is not a part of core Kubernetes. You either need to install it as an additional component or enable it on your Kubernetes managed solutions like GKE with the appropriate cloud provider-specific commands. Then you create a VPA object pointing to your application in a similar fashion as in HPA. However, there is no dedicated kubectl command yet. Okay, now the list of best practices for VPA. As mentioned earlier, start your adventure with VPA in recommendation-only mode. Give it a while, like a day or more. Convince yourself that the recommendations are good, and then consider switching it to auto. When running in auto mode, set your pod disruptions budgets. It will allow VPA to know how much pods can be updated and killed at the same time. Actually, you should set pod disruption budgets in many other situations, so please do. When configuring VPA, set minimum and maximum container size in VPA object, just to be on the safe side in outage-less situation. For example, when the traffic is not coming to your application for hours or maybe even days in severe outage, VPA might reduce pod sizes significantly. And then you will have a very unpleasant surprise when the traffic suddenly is back. VPA looks for a longer time horizon and doesn't immediately adjust the recommendations. So after the situation, if you don't set minimum, your pods will be small for some time, too small. VPA doesn't update deployment specification. It only updates pod requests on newly created pods in admission control chain. So a good practice is to put reasonable pod requests taken, for example, from VPA recommendations in the deployment itself, just in case, for example, someone turned off VPA accidentally. VPA doesn't like huge, abrupt changes. For example, if you have 30 pod replicas right now, please don't change it to 5 in one step, but do it gradually so that VPA can adjust. VPA stores history. A very significant change in your application, like completely new version, completely new behavior, may require a new VPA. And to do it properly, you should create a new deployment with a slightly different label set, because VPA catches pod usage based on a label set that they have. VPA takes metrics from metric server, so in a similar fashion as in HPA, it is important to keep it healthy. And in the same way as in HPA, you should enable cluster autoscaler in your cluster. Can you mix horizontal and vertical pod autoscaler on the same workload? Well, the short answer is no. The more detailed answer starts with execute cautions, and it depends. Technically, you can always use VPA in recommendation mode. It is safe, nothing is changed, and nothing bad should happen to you. However, in order to get stable results, you should either use custom metrics in HPA or absolute values for HPA target when scaling on CPU, because VPA recommends you changing pod sizes, and relative values will be affected by this change. And you should make sure that your application gets enough traffic. HPA should not be at its minimum number of replicas all the time. And then when you combine HPA and VPA, then switching to auto is risky and should be only done when you deeply understand HPA, VPA, and your workload characteristic. Okay, few words about potential savings. With VPA, you only request the resources that are actually needed. Without VPA, you use your best guess or maybe some monitoring for providing pod sizes. Usually people significantly over-provision, sometimes a couple times. Now the third and last robot, Cluster Autoscaler. Horizontal and vertical pod autoscalers are targeted at scaling user workloads. Cluster Autoscaler scales the underlying computing infrastructure. It provides nodes for pods that don't have a place to run in the cluster. It also compacts the underutilized nodes. It is based on scheduling simulation and declared pod request. It doesn't use any metrics, like actual CPU usage or, I don't know, observed QPSs. So let's take a look on how does it work in practice. Here we have 4 pods. 3 pods are big, 1 is small and leaves some free capacity on its node. If a new pod comes, then it may actually fit on this third node and scheduler will place it there. However, if all nodes are kind of full and the scheduler has no way of placing the pod, a new node is needed. And then Cluster Autoscaler comes into action. It talks to your cloud provider and spins up a new node. The new node arrives, and scheduler puts the pending pod on the new empty node. On some other occasions, some nodes might not be utilized to their full potential. Like on this picture, small yellow and green pods have nodes for themselves. However, if we move the green pod to the third node, we'll get a free node that can be safely deleted, like this, reducing your monthly cloud provider bill. And this is exactly what Cluster Autoscaler does. It removes and adds nodes to your cluster as needed. When to use Cluster Autoscaler? The short answer is always, especially when you have more than 2-3 nodes and your cluster workloads change in time. Cluster Autoscaler works with multiple cloud providers. We have support for Alibaba, AWS, Azure, Baidu, DigitalOcean, Google Cloud, OpenStack, and Packet. Plus, there are some cloud providers supported out of the core Kubernetes/Autoscaler repository, which we, as SIG-Autoscaling, don't closely follow. To enable Cluster Autoscaler, please follow cloud provider-specific guides. Some environments, like GKE, have built-in easy-to-use switch to turn on Cluster Autoscaler, but many require additional manual stuff, so please check the appropriate documentations for details. Best practice. Use the hosted version of Cluster Autoscaler when possible. Pick the version of Cluster Autoscaler that matches your cluster version. There might be some subtle differences between versions of scheduler, which might result in inconsistent Cluster Autoscaler behavior if you take old Cluster Autoscaler and put it on new cluster or vice versa. And define pod disruption budget for applications. It is particularly important for the compacting phase of Cluster Autoscaling, and it controls the number of replicas that can be taken down at a given moment. I mentioned it with VPA, but it is also very useful here. Okay, savings. Cluster Autoscaler will drive your cluster utilization about 10% above scale down threshold, which is by default 50%. So utilization will get somewhere around 60% in terms of requested capacity, calculated as a sum of all pod requests on your node. If you want to learn more how to squeeze more performance from Cluster Autoscaler, please come and join us on SIG-Autoscaling Deep Dive tomorrow. Without Cluster Autoscaler, your utilization depends on your own bin packing skills and a bit of luck. On a large cluster, on average, the utilization is significantly lower than it could have been with if you had Cluster Autoscaler enabled. As this talk is slowly getting to the end, I would like to give you a little bit more information about the SIG-Autoscaling itself. We have meetings every Monday. As most of our current contributors are in Europe, the meetings are held at 4 p.m. European time, which is unfortunately 7 p.m. on the West Coast. And we have the meetings on Zoom. The link is here, but you can also find it on Kubernetes documentation. We have quite active Slack channels, so if the meeting time doesn't suit you, feel free to ask your questions, concerns, or new ideas, put your new ideas there. Most of our staff, Cluster Autoscaler and VPA, sits in Kubernetes/Autoscaler repository on GitHub. HPA itself is in the core Kubernetes/Kubernetes repo. And as I said, we have SIG-Autoscaling deep dive on Wednesday at 11:50. My colleague Vivek will tell you more about Cluster Autoscaler, options to debug it, and options to fine-tune it. Thank you. This is the end of my talk, and now we have a couple minutes for questions. Okay, do we have a mic runner? Perfect.
Hi. You're good? Oh, I'm good. Okay, so I'm Yuan Chen from JD.com. You would not recommend the mixing of the VPA, HPA, but in our case, we do see a need, in particular when we run the stateful application there, right? We want to do VPA first, but if it exceeds the capacity of the nodes, and we have to do the HPA. So I just wondering in the community and any plan, or you do not see a need for this mixing of the HPA, VPA, even the CA, and find the integration everything together?
Yes, we would love to. Oh, I have mic, don't worry. Yes, that's a known problem. So far we have been working on graduating VPA itself. It has been marked GA this summer/autumn, so the next step would be to making sure that all the environment works together. Right now, so far we have been focusing more on making sure that individual building blocks are okay. So we are aware of the problems, working on it. Hopefully we'll have some good solution soon.
Nice talk. Question about, could you elaborate a little bit about how does the Autoscaler work in terms of defragmentation? Assuming, for example, in my cluster, I have a large pod that consume a large portion of the node mix with really, really small pods. How, because, do you understand a little bit my question?
Yes, so you'd like to have more information how Cluster Autoscaler removes nodes.
Yeah, so when it does the defragmentation, or do they actually force to evict nodes from other pods, or what's the life cycle when they are trying to compress?
Do you have... Sorry. Okay, maybe I will move there. Okay. Do you have free time tomorrow at 11:50?
Okay, they're going to explain that?
Yes. Please join.
Hi. Question. Cluster Autoscaler, you mentioned that it's providers, so it's only hosted clusters, or on-prem clusters can work with that as well?
For on-prem, the situation is different. Not sure how your on-prem is organized. If you're using VMware or whatever, I heard that VMware might
I mean, so we're using, our cluster is on AWS, but it's all EC2 based, so we build it our own way, Terraform and Ansible. So is there any way to integrate Cluster Autoscaler with our automation and utilize that? Or it works only with providers?
So we support AWS, so if you're on AWS, you can enable Cluster Autoscaler there. There is quite extensive documentation how to do it on our GitHub, in our GitHub repository. And you were mentioning something about on-prem, right?
Well, what I'm trying to say that it's not. What I'm trying to say that our cluster is not like we use EC2, but we build it from scratch ourselves. So we're not using the AWS hosted cluster. Okay, so that's okay. So you can use it with purely vanilla Kubernetes installed on your own and manage on your own. The sources of Cluster Autoscaler are freely available, so you can go there, get all the either
ready release or compile it by yourself, put it in your cluster, and it will work.
Okay. Thank you.
Hi, I'm Ketan from IBM. I have two questions for you. One for the cluster autoscaler, you mentioned it doesn't monitor for metrics on the CPU or memory. It notices, say, pending pods and does the scale-up operation. What are some of the ways or approaches you can suggest for having the autoscaler trigger a scale-up operation based on some sort of threshold on the CPU or memory when on the cluster utilization rather than noticing the pending pods? And the second question around the VPA.
Maybe let's do it one by one, because I will forget what the first question was about, okay? Sorry, I have limitations. Why cluster autoscaler is not working on metrics? So cluster autoscaler is already a complicated beast, and we decided that we will separate autoscalers. Workload autoscalers work on metrics because we can actually observe the metrics there. And if you want to optimize the pod shape or the number of pods, you should use HPA or VPA respectively. Then cluster autoscaler assumes that the workloads are kind of already optimized. So they are not overrunning their pod requests, and you have the correct number of them. So each of the node is kind of healthy. So it's not that you requested just half a node and you are trying to use twice of the capacity. So this is the assumption that is in base of cluster autoscaler, and then we use scheduling simulation to decide whether you would need one extra node to handle the pending pods that you have, or maybe 5 extra nodes, and decide based on various heuristics what shape of the nodes should be if you have multiple autoscaling groups, node pools, or whatever your cloud provider has.
Yep. Yeah, thanks for the insights on that.
Okay, the second question?
Second question on the VPA. You mentioned VPA doesn't necessarily act on the, changing the metrics, but it provides us suggestions and acts on any newer started pods. And there can be limitations if we have resource quotas based on namespaces and deployment level, and doesn't make any changes to the deployment itself. Would you suggest we should, leverage VPA to make changes to the namespace level quota or deployment to automatically end-to-end, leverage VPA, or would it be not a good idea?
So VPA does pod changes before the quota is checked. So if you have quota, VPA, the updated pod will pass. If you don't have quota, then obviously the pod will be rejected. So quota is fully respected, and most people set up quota for incompatibility reasons or to reducing the cost of the development or whatever. And right now we haven't seen much need for updating quota itself in VPA. What was the second part of your question?
Would you suggest it might be a good idea to leverage VPA to make changes to the deployment template quotas or namespace?
So we thought about doing changes to the deployment. However, any change to deployment triggers pod recreation. And it doesn't necessarily adhere to pod disruption budget. So it could have more severe effect on your deployment that you would wish. So at this moment, we have no plans to update the deployments because of pod disruption budget issues. And secondly, deployment store history. So every single change you made to deployment is stored there. So if a vertical pod autoscaler is doing, let's say, 10 updates per day based on the changing patterns or so on, your valuable history would be completely overwritten by not so valuable VPA activity. So at this moment, there is no way to change things in deployment without writing it to the deployment history. And for this and a couple of many of other reasons, we decided that we will rather stick to pod updates. And ask users to update the deployments by themselves, but if you have strong case, please come to SIG-Autoscaling meeting on Monday and we can discuss it further.
Sure, yeah. Thank you for answering.
Thank you.
Hi. Just wanted to ask, does the cluster autoscaler kill unhealthy nodes, or is that a different problem?
Cluster autoscaler will kill unhealthy nodes. So we monitor the situation of the nodes, and if node is unhealthy and your cluster can be scaled down, so you set the mean and max cluster size accordingly, we will delete the node. However, if you are already at the boundary of your cluster size, we will not delete the unhealthy node. And the unhealthy node deletion will happen, I believe, like 20 minutes after we spot that it's not ready or something like that.
Okay, thank you.
How does the vertical pod autoscaler and the cluster autoscaler handle differing CPUs between on-prem cloud and EC2 instances? Because not all CPUs are created equal.
So we kind of assume that CPUs are equivalent in the same fashion as Kubernetes assumes. So when you request some capacity in pod request, you just specify one CPU. You don't specify it, I don't know, in MIPS, teraflops, or whatever. You just say one CPU and you hope for the best. So unfortunately, we don't have any extra tooling except like pod request or maybe label selector in your pods to ask for particular performance of the machine.
Is there any plan on adding that work, or is that work?
I'm not aware of any
on
Kubernetes-wide effort to request, I don't know, MIPS, teraflops, whatever in pods. So. But you can try to bypass it by setting the label selector on your pods so that this pod runs only on the newest Intel architecture and some other pods can be run on some older stuff.
In case of HPA, when the pod downscales, which pods will go down first, the oldest or the newest?
HPA uses deployment logic to scale down deployment, and a random pod will be killed.
There is no strategy on which one will be?
Unfortunately, that's how deployment works. And if deployment changes the strategy for scale down, we would get it automatically. Plus, we work with any Kubernetes object that has scale sub-resource. So the strategy is not only limited to deployment. Deployment itself doesn't allow you to kill a particular pod, so we cannot do it from the HPA itself. So our hands are a little bit tight, and random pod is killed. Sorry for that.
And in case of node autoscaler, say if multiple pods are pending, the worker nodes will be autoscaled.
Sorry, could you please?
If multiple pods are in pending state, and then we have the nodes that will autoscale, right? Once pods downscale, which node will be killed first, the worker node?
So we have various strategies there, deciding which node to pick. The first thing is that we will pick nodes that are less utilized. So we have the threshold, and nodes above a particular threshold will not be touched. So for example, by default, we consider nodes that have at least 50% of their capacity used as well utilized, and we don't compact them. You can change it. If you want to learn how to change it, please come on Wednesday to the talk. Otherwise, we choose some nodes that allows us to delete the pods. Some pods may have pod disruption budgets. Some nodes may be holding like important system components, and even if they were like the best candidates, they cannot be killed because there is a metric server running there, and killing metric server could cause an outage, or there is a DNS server or something like that. So the actual strategy there is a little bit more complex.
Thank you.
I'm afraid I have run out of time, so if you have any more questions, please join me outside of this room. Thank you.